Hello, everybody. We are going to be looking at lesson 2.11, which is introducing absolute value bars. Now, maybe you have seen these before. These are the little vertical line bars that you'll see that hold an expression or a term, and this is called the absolute value of x. As we drag the point along this number line, we can kind of discover that the absolute value of -2 is 2, -3 is 3. We just kind of notice the pattern of what absolute value means. Absolute value of 7 is 7. We notice those numbers are similar on the left and right. When we have a negative sign inside the bars, the absolute value of that becomes positive. And the reason for this is because the absolute value of x means how far away x is from 0. So it is the distance from 0, distance is always positive. So that's why we notice when we have the absolute value of -4, it's a positive 4 because -4 is 1, 2, 3, 4 spaces away from 0. So we're counting and figuring out how far it is from 0 to get the absolute value. Let's do some exploring with this on slide 2. So it says here's one solution to the absolute value of x is 4, right? Because this is 4 spaces away from 0. Drag another point to another solution where the absolute value is 4. So let's go 4 in the other direction. 1, 2, 3, 4. So this also has an absolute value of 4 because it also has a distance from 0. So -4 is 4 spaces away from 0, so it also has an absolute value of 4. Beautiful. When you're all set, go to slide 3. Drag the point to show that the absolute value of x is less than 4. So any distance that is less than 4. So this could be 2, right? The absolute value of 2 is 2. Here's some other points from your classmates. You can change your placement and move it wherever to kind of see what the vibe is. And it says, are any of these points incorrect? So if we want it to be less than 4, then we want that absolute value to be smaller than 4. So it could be 3.5, 3, 2.5, 2, all the way down to 0. And then we can go the other way as well. So everywhere highlighted along this number line now is going to have an absolute value less than 4. This one looks like it's equal to 4, which we don't have the equal to line underneath, so that's wrong. And then this has an absolute value of 7, and this one has an absolute value of 6. So those ones would be incorrect. And there's infinite solutions because any point on this number line between 3.999 and -3.999 is going to be a solution. Beautiful. Let's look at the next slide. Here are all the solutions to when the absolute value of x equals 4 and when it's less than 4. How are these solutions alike and how are they different? Well, one thing that we notice about them being alike is we're kind of gathered in either starting or ending at 4 and -4, right? So the two solutions have that same boundary point of -4 and 4. Obviously, we see that there are some differences here. The solutions to the equation above in the top one are -4 and 4. and they are closed circles because they contain those two values. While the solutions to the inequality are all the points between -4 and 4 and have open circles because it can't be equal to 4 or -4, it has to be less than. Beautiful. Let's look at slide 5. Which number line represents the solutions to the absolute value of x greater than or equal to 2? So greater than or equal to means we're definitely going to have a closed circle, which is great. All of these do. And we want that absolute value to be bigger than 2. So it can be 2 spaces away from 0 or further. 2 spaces away from 0 or further. So this one would just be x is greater than or equal to 2, but not the absolute value because we are missing something on the negative side. So that's not going to work. B starts at -2, but these values here do not have an absolute value bigger than 2. Like the absolute value of this point is 1, which is not what we're looking for in our criteria. So this is wrong. When we look at C, some of these have absolute values of 1 or absolute values of 0. So again, we don't want it, that would be if it was less than. But what we're looking for is D, which has all the absolute values to the right, that'll be bigger than 2, and to the left, that'll be bigger than 2. So like this has an absolute value of 5. This one has an absolute value of 4, right? We can get those numbers that are greater than 2. Beautiful. Slide 6, my friends. It says Philippe is graphing the solutions to 2.5 less than or equal to the absolute value of x. Here is some of his work. Describe how Philippe's work can help him decide where to shade the solution set on the number line. So we know that our boundary points, right, are going to be at 2.5. So notice there's a dot here at 2.5. And there's a dot here at -2.5. And between those two dots, we have 3 sections. We have a section to the left, we have a section in between them, and then we have a section to the right. So Philippe tested a point in each of the sections of the number line. On the left, we got a true statement because -5 has an absolute value of 5, which is bigger than 2.5. In the middle, we got a false statement. So this is not going to be where we shade because the absolute value of 0 is 0, which is not bigger than 2.5. And on the right, we got another solution, correct, because the absolute value of 5 is 5, which is bigger than 2.5. So he is going to shade the regions that make the inequality true. So in the middle, we are not going to shade because that's a false statement. So we don't want to color in that area. Those have absolute values that are less than 2.5, which is not what we're looking for. Beautiful. Slide 7. Says Paulina says that the value of x minus 2, or the absolute value of x minus 2, is the distance between any number and 2. Drag the points to see different values of the absolute value of x minus 2. So it takes the number that we're putting the point on and subtracts 2, like so. Do you agree with Paulina? So when you subtract the 2, you are finding the difference between the x value, wherever we are in the number line, and 2. So yes, that is the same as the distance between x and 2. Beautiful. So let's look at slide 8. Describe or show all the solutions of x minus 2 equals 4. So for part A, it's wondering which solutions, if you subtract 2, that are going to be 4 units away. Okay, so let's take a look at this graph. Okay, so we're looking at numbers that are 4 units away from 2. So if we go to 2 and we count 4 to the right, here's 6, right? Because 6 minus 2 is 4, and the absolute value of 4 is 4. And then if we go to 2 and go to the left, we get negative 2, right? Because negative 2 minus 2 is the absolute value of negative 4, which equals 4. So there's our 2 points, at negative 2 and at 6. We have 2 solutions. Down below, well, I'll just put our response in for A, which is the solutions are all the points that are 4 units away from 2. Now for B, we're still looking at those same boundary points of negative 2 and 6, but now we're looking, and I'm going to do a closed circle because it's less than or equal to. So now these are all the numbers between negative 2 and 6. All of these values are between negative 2 and positive 6. So all of these will have an absolute value of 4 or less. Beautiful. Okay, slide 9 when you're ready. Okay, it says compare and contrast. 2 students graph the solutions of the absolute value of x minus 2 is less than or equal to 4. How would you describe each student's strategy? So over to the left we have Essie, and they made a mark at 2 right here, and then counted 4 units to both sides. This is kind of what we did with the graph. 4 to the right gets us to 6, 4 to the left gets us to negative 2, and then they shaded in between those 2 numbers. Now there's another way that we can do that Deja did, where they wrote 2 separate equations. They said, okay, x minus 2 is going to be equal to 4, or negative x minus 2 is going to be equal to 4. So add 2 to both sides to get x equals 6, and divide by negative 1, and then add 2 to get x equals negative 2. So they used math, algebra to figure out what those 2 boundaries are, and we're going to talk about how you can use our equation practice to solve absolute value equations and inequalities as well. At the end, also, Deja tested the a point in between them to see if we were going to be shading in between them or outside. Beautiful. Slide 10 is a card sort. So we have 1, 2, 3, 4 inequalities in 4 graphs. So let's look at the first one, which is the absolute value of the distance from 1 is greater than 3. So we are going, our distance from the number 1 is going to be bigger than 3 away. So let's actually, you know what, I don't want to run out of time with the card sort, so I'm going to pause the video here and come back for part 2, and we'll finish out the amplified activity. Okay, see you in a moment in part 2.